Welcome everyone to my LeetCode Biweekly Contest 129 live stream. In a few moments, we'll be starting the contest. We'll be doing it live. We'll be answering questions and giving hints in the chat. So join us every weekend for the contest, and we'll do it together. No code will be shared during, but immediately afterwards, we'll go through solutions for all 4 questions. So make sure to stick around. And if you enjoy LeetCode content, make sure to check out the rest of my channel. I have videos on different problems. I have solutions to the hardest question 4s from previous contests. And as usual, like and subscribe to stay up to date on new videos. Okay, I see people in the chat already. So make sure I just get signed. Hey! Hi Naveen, hi Scientific Coder. I think I recognize you, Scientific Coder. So welcome back, folks. We still have about 6 minutes before the contest starts. So let's see. Yeah, we'll just hang out a little bit. How are you guys doing on the daily problems? Do you guys do daily problems? The last 2 daily problems were all hard, but they are actually super easy. And they are basically the same problem, explained differently. So I thought that was kind of funny. Like, let me see if I can bring it up. I know on Thursday, Friday, the longest ideal subsequence. Oh, it's medium. Oh, this falling path. This one, it says hard, is actually really easy. It's only a few lines. Oh, it's actually a few more lines. But these 2 questions, even though they are both hard, they're the same exact question. They're just like phrased differently. And I'm pretty sure that they are the same question as appeared in one of the previous contests, like last week or 2 weeks ago. I don't remember. I remember doing a question that's exactly like this. It's the same strategy, just slightly different. So I thought that was kind of funny. As you guys can see, I'm on a 62-day streak. I really like my contest streak. I work very hard to keep this because sometimes I'm busy the whole day. So I need to find some time to work on this. There was at least one time to wake up in the middle of the night just to do the just to do the daily problem, so I don't lose my streak. So these guys really have me. They've really got me. Yeah. Let me see if I can just pick a warm-up problem to do while we're waiting for the contest to start. Not that there's a lot of time though. 3 minutes. Let's pick an old one that I didn't do. Range sum of BST. Given the root node of a binary search tree and 2 integers low and high, return the sum values of all nodes with a value in the inclusive range low and high. Oh, this is pretty easy. Excuse me. So this one is pretty straightforward. This one, just do a some kind of recursive search. Some people call this a depth first search, but I don't believe, because it's a tree, I don't really think, such a term applies. Just recurse down the tree, find all the numbers, and then when you see a number in the low high range, you just return it. It's not too hard. Hey, Hackers.io. Hey, bro. I'm good. How are you? I recognize you from past couple weeks. If I don't remember wrongly, you actually do pretty well each time. Is that right? I remember you being in the chat a lot. How's it going? How's it going? I'm just doing a warm-up problem. Oh, the contest almost starting soon. Let's come back to it. 30 seconds. I'm good, man. Yeah, buddy. Where are you from, Hackers.io? Are you also... I think most of my viewers are from India. Are you also from India? Hey, Upendra Raj Joshi. Yeah, hey. You know, I should learn some Hindi sometime. I actually have a lot of friends from India because I did CS in college. So all my college friends, all my college friends are Indian. Even though I went to school in America, so all of my college friends in America are Indian. So I should learn some Hindi. I should get them to teach me. Anyway, contest has started. Good luck, everybody. We're off to races. If you have questions, make sure you write in the chat. Good luck, Anonymous. Good luck, Shirish. If you have questions, write in the chat and I will answer. Questions, if you want hints, whatever you want, just let me know. And sometimes other people answer. People here are pretty nice. Yeah, just FYI to folks who are new, welcome Pranif. You're going for Code Forces, Div 2? Ah, interesting. I have thoughts on that. I'm not that much of a fan of Code Forces. I think their questions are too competitive programming style, whereas LeetCode questions are more like real life, a bit closer to real life software engineering. Not that close. Hey Rohan Sharma, how's it going? Naveen, I don't share code. I don't share code, unfortunately. But we will go through it after contest. Give some ideas about first question? Sure, no problem. That's what I'm here for. Okay, you need to make a square with the same color, right? So think about what you need to do. Basically, your output is for each. Okay. So make a square the same color. You're given 2D array 3 by 3, so you know the size is fixed. Each square is either black or white. So you can see this picture. Your picture probably looks better than mine. So some are black, some are white. Okay. So your task is to change at most one cell so the matrix has a 2 by 2 square where all cells are the same color. Return true if it's possible to change at most one cell, 1 or 0 cells. So for instance, you can have, for this example, you can change, you look at this 2 by 2 square, you can change this guy on the top right hand corner, and this 2 by 2 square will all be white. Okay, so that's true. For this one, there's no 2 by 2 square you can pick, right? There's like this. There are only 4 2 by 2 squares, and all of them, whichever one you pick, all of them has at least 2 squares of a different color. So there's 2 parts to this problem. One is you need to know how to find all the 2 by 2 squares in the matrix. So you need a nested for loop for that. You need to find all the 2 by 2 squares. Or if you don't want a nested for loop, there are only 4 2 by 2 squares. So, you don't even need a for loop. The second part is you need to see, given a set of this 2 by 2, you need to be able to tell whether you can turn them all to the same color by changing the color of at most one cell. At most one cell. So what does this mean? That means 3 cells, same color. So you need to check if there are 3 cells with the same color. If there are, you're done. So that's all. I hope that was helpful. See. So why am I live? I'm live because I can talk to people in the chat. Yeah. Thanks. No problem. Thank you, Astic. How to check conditions in question 1. Yeah. So you have to check that all 3 cells are. I can't share the solution, not code. Because LeetCode is a contest, right? So in a contest, you can't share answers. That's the whole point of contest. But if you stick around until the end, we will go through all 4 questions and I will share all the answers. Yeah, so LeetCode is they actually run a similarity checker. So if your answer is exactly the same as somebody else's answer, they will catch you. So there are a lot of people who do this, but I'm not going to do it. And anyway, we're all here to learn. If we just take the answer, then the learning value is reduced. Just try it yourself first. At the end of the contest, I promise you, we'll go through all the code, so you'll have all the answers at the end of the contest. Done and dusted. Nice. I love that. I love that saying. Can we see your LeetCode profile? You can look at my LeetCode profile. My rank is not very high, I'll tell you that. My LeetCode profile is just my username. So Alex does LeetCode. I will tell you that I've never won a contest, but I've gone to every single contest. So that's my claim to fame. It's not that I'm good, it's that I work very hard. And I think if you work hard, you're going to succeed. You don't have to be naturally talented. Yeah, so question 2 is kind of tricky. I'm curious what happens if you have like a square with all 4 ones. So I'm a bit curious, but they didn't reckon. They didn't say. Oh, interesting. Oh, the 3 elements do not have to be next to each other. What the same row in. Interesting. Just checking every 2 by 2 matrix. If any color occurrence is greater than the other color, then return true. Yeah. Sort of. So every 2 by 2 matrix, it needs to be actually. I need to change this hint. This hint is not correct. It's not 3 cells. It's yeah. 3 or 4 cells. So basically only 2 cells. Yeah, this was wrong. Hi, Ayush, no problem. If you're a beginner, just try your best. We will go through answers at the end, though. At the end of the contest, we'll go through all the answers. So don't worry about it. And if the contest, you find the contest is too difficult for you, don't worry about contest. Just go to the rest of my channel and look at some easier problems. I have some easy problems, even though most of my content is contest oriented. The contest tends to be a bit harder. So if you can't solve the contest once, it doesn't mean that it doesn't mean that you're not good. It just means that they are too hard for you. Hi, Naveen. Unfortunately, we don't share code on this channel. Just because it's a contest. We will talk about all the solutions at the end of the contest. But while the contest live, it's a bit unfair, right? Because if you sort of copy other people's solutions, and it doesn't help you learn also. If you want hints, or you want to ask questions, I'm happy to help you. Or actually, a lot of people in chat are happy to give you hints. If you want the solution so you can look at it, just hang on tight, wait until the end of contest, and then we'll share all the solutions. So don't worry about that. But meantime, try to see if you can get it on your own first. It's a good way to also learn and also to test yourself, right? So if you see yourself getting more and more questions over the week, then you know you're really learning. Wow. This question 2 is harder than most normal question 2s. Damn it. Okay. Hint for question 2. Question 2 will be done using hash map. Sort of. I'm using a hash map. Actually, no. Let me see. I'm using. You can use a hash map. You don't need to. You don't need to. Yeah. You don't need to. Question 2 is kind of annoying because you have to count a lot of. Basically, you should go to, like the way I did it. You go through every column. If the column has 2 things in it, then for each pair of things in the column, see if you can make a triangle. Yeah. First done it. Hey, Red Finance, welcome back. Welcome. Approach of question 2. Yeah, let me see if I can go to question 2. Okay, so question 2 is like this. Question 2 is a little bit annoying. So you're given a 2D array grid. You need to return an integer that's a number of right triangles that can be made with 3 elements. What's a right triangle? It's got a really annoying definition. Basically, a right triangle is 3 things that can form a triangle. So this will be the right triangle. Okay? There's no right triangle. Like this, and this. This is not. Okay? This is a right triangle. So this is a right triangle because you can do like this. Okay? So you count how many possible triangles there are. So think about what are the ingredients for the right triangle, right? You think about general case. You think about here, if you think a specific case, it may not work. So in the general case, what's a right triangle? Right triangle is 3 squares that are ones that can form a triangle with each other. Okay, something like this. So how do you find something like this? Well, here's the thing. First thing you do is you go down every column. If you see more than 2 ones in the same column, then now you have to go down their row and then find the third one. So if you go down, let's say this column, and you see 2 ones here, then you want to see if there's a third one here, right? If there's a third one, that's a triangle. Okay? Now the tricky part is if you do this naively, I think I didn't try doing it naively, but I think you'll actually go get a TLE because there's the n is 1000, right? The n is 1000. If you do this naively, I think it's n cubed, which will give you a TLE. So what you can do is instead you can just remember what are the numbers here. What are the numbers here? Let's say there are 2 numbers here, this one and this one, right? You just count how many and remember where their positions are. Okay? You go through like a pre-processing to find out how many. So the way I did it is how many ones there are on each row, and then for each column I do and I guess you can use a hash map, but I just use a set what the positions are. And then let's say there are 3 ones here. So you'll find for each of the 3 ones how many right triangles you can make. There's like 1 here and 1 here. So this number is 3, right? So this means that this and this can be a pair, and because this and this is a pair, you get 2 here. This and this is a pair, you get like another 2 here, and so on and so forth. So the number can be quite big. Yeah. So you can try it out and see if you can, if that makes sense to you. I hope that was helpful. Nice, very nice. Well done. Okay, so for second question, yeah, while I'm waiting for this slow thing to run. So for second question, once again, you have to first understand what a right triangle is. The right triangle can be like, it's almost like anything, right? The right triangle is like a weird definition. But the idea is you need two things on the same column and one thing on a different column but the same row as them. If you have that, that means you have a right triangle. So for instance, let's say your grid looks like this. You will have a number of triangles. You have this, you have this, you have this. 3 different right triangle. Actually, you have more than that. You have this. 4 different right triangles. So how do you do that? Well, the way I did it anyway is I look at, all the for each column, I find all pairs of ones, and for each pair of ones, I count how many of them have like an additional thing here. So that's how I did it. Yeah, for each column, I just check if the column has more than one in them. If there's like 2 ones or more, then I just look at each pair of ones, and for each pair of ones, I calculate, right? The other thing I do is count how many there ones are there in each row. So I just multiply. So let's say there's like this guy, and this guy. So you know that this 3 here is multiplied by this number here. Yeah. Please don't spam. And don't share any code here. I'm gonna ask people not to share code here because it's a contest, right? So for competitive integrity, you don't want to share code. And I'm pretty sure LeetCode doesn't. Yeah, LeetCode will not be happy if you do that, and they will find you. Okay. Yeah, finally I'm getting to question 3. So question 3 and 4 is the same, but question 4 is the harder version. I think it's they always do this. Yeah, sure. While I'm waiting for the thing to compile, I'll go through question 2 again. Question 2 is actually really hard for question 2. It's not difficult, it's just hard for question 2 standards. So basically what I did is basically first thing I do is to pre-process. For every row, I count how many ones there are. Okay? So let's say this is my matrix. Then yeah, maybe I have one more here. So this will be 2 ones. This will be 1. This will be 3 ones. Okay? So for every row, I count how many ones there are. And then for every column, I go through the column and I sort of figure out where the ones are. So the ones are at the ones are here for this column. For instance, for column 1, the 1 is at here, here, and here, right? So I have 3 of these guys, and they are here, here, and here. So what is the number of triangles I can form? Well, the number of triangles I can form where with this row, this column having 2 ones, is simply going to be the number, is simply going to be the each pair of these, and then multiplied by these guys, right? So for instance, if there are 3 things here, let's start with 2 things here. If there are 2 things here, right? If you look at this column and you focus on this guy and this guy, right? You wonder how many triangles can I form with this guy and this guy? Well, the answer is the number of other ones in the same row as them. Okay? So for instance, this guy and this guy, I can form 1 triangle here and 1 triangle here because this guy has 3 ones. So there are 2 other ones in this row. There are 2 other ones in this row that I can use to form the third side of the triangle. So for every column, I find 2 guys. This will form, one side of the triangle. And now I need to find a third guy. So for third guy, I go to each of their rows. I go to this guy. This guy is the only guy on his row, so he can form 0 new triangles. This guy has 2 other guys on his row, so he can form 3 triangles. 3 minus 2, which is 2 triangles. 3 minus 1, which is 2 triangles. So for the pair this and this, I can form 2 triangles here, right? I'll just draw them out. Okay? Now, what happens for this pair, and this pair? How many triangles can I form? Well, here is going to be 3, and here is going to be 2, right? So with this guy and this guy, these 2 guys as the sort of spine of the right angle triangle, I can form 1, 2, and 3. Yeah? So you see the pattern? So how do I know it's 1, 2, and 3? Well, it's the number of ones in their rows combined. This guy's row has 3, and this guy's row has 2. So 2 minus 1 is 1. 2 means 1 guy other than himself, and this 3 which is 2 guys other than himself. So you take this 1 plus 2, which gives you 3. I hope that helps. Okay. Now I got to work on my own problems too. Yeah, sorry, I got to work on my own problems too. Everybody got their own problems to work on. Total number of stable subarrays. This is going to be super large. Oh, it's not that large. Wait, why is it so large? That's interesting. 2 stable subarrays. Oh, okay. I see. Oh, it's going to be super large because you're not given array. You're talking about any array. So it's a permutation problem. Each subarray of R has a size greater than limit, must contain both ones and zeros, which means that they cannot contain. Oh crap! So they cannot contain. Okay, which means they cannot contain. They cannot contain more than limit ones or zeros in a row. So they cannot contain more than like ones or zeros in a row. So it sounds like it's a permutation problem, right? You just calculate how many arrays, total arrays there are. You calculate how many okay, you calculate how many total arrays there are, and then you calculate how many of those arrays have at least limit zeros or limit ones in a row. Correct? I think so. It's a permutation problem, I think. LeetCode B done. Nice. Hey, Mahesh Yadev. I will teach after the contest. Yeah, sorry, Astic. So for context, question 2 is actually much harder than the usual question 2. Usually question 2 takes like 2 minutes. Or like maybe 10 minutes to solve. But this question 2 seems harder. Question 3, I think, is a permutation problem. We are not taking subarrays with the same arrays with the same subarray. Aren't we taking them in test case 3? Yeah. Question 3 seems like a permutation problem. All the possible subarrays. Limit 2. Yeah, I think first you have to count how many subarrays there are. Ah, crap. I forgot my permutation. So it's like n choose. Yeah, like n choose k, right? N choose k. So, I'm not trying to convert anybody to Python, but Python has a built-in function for doing combinations. And while I'm saying that, I'm pretty sure I'm pretty sure Java also has a built-in function that does combinations. So the first thing I think, let me see. This is hard. But I don't get why. Yeah, I don't get it. Never mind. I'll work on it first. So it's just combination. Okay. What are the ones above and no exactly. What's so hard about question 4? I don't know. I haven't gotten yet. I'm still working on question 3. As you guys know, I talk a lot, so I need to do less talking, do more working. So question 3, it looks like you take all combinations, and then you count how many combinations are there with limit plus 1 once. If once larger equals to limit plus 1. Interesting. Oh, I got a bug in my code. Hey, Mahesh Yadev, I'm gonna ask you to not spam. Sorry about that. Okay, let me look at the answer to chat. Yeah, thanks, Rohan. Appreciates that. Appreciate you saying that. Okay, I'm also working on question 3. I think this is combination. This is a like combinations problem. It's a math problem. It's not a programming problem. I don't think it's a programming problem at all. I think it's a math problem. Okay, so questions for question 3. And sorry, Kumar, I think you're asking for question 2. I'll come back to it after the contest ends, okay? Or if I have time after I finish my own. Yeah. Yeah, it's a PNC problem. Yes, it's a math problem disguised as a programming problem. Come on. Yeah, so am I, Daddy. So am I. Okay, Prajwal, Solanke. I am actually I teach. So I teach at a university. So I used to work as a software engineer for about 10, 15 years, but now I teach at a university. So I'm neither a student nor a professional. I guess I'm a professional teacher. You're given 3 positive integers, 0, 1, and limit. And R is stable if the number of occurrences is exactly 0. Number of R is, yeah. So this one just tells you that you have to create arrays with 0 zeros and 1 ones. Okay? This just tells you what numbers there are in the array. And then you can just jumble them up, right? It's a permutation problem. It's a combination permutation problem. Okay, the third constraint is the interesting one. These two are not interesting constraints. Third constraint is interesting. Each subarray of R with a size larger than limit must contain both 0 and 1. Okay, so I think the strategy is you have to avoid R who has more than limit 0 or limit once in a row. So for instance, let's say limit equals to 3. Okay, so 0 0 1 0 0 1 1 0, whatever, this is fine. But once you have 0 0 0 0 1 1 1 0, this is not fine, because you have this combination, this like sequence of 4 things, 4 zeros in a row. So you cannot have more than limit limit items, limits identical items in a row. Okay? So yeah, that's the question. That's the question the way I understand it. I'm still working on it. I don't know if my answer is correct. So my strategy is step 1. What's the total number of binaries that you can create following the first two constraints with 0 zeros and 0 ones? Okay, so that's just n choose k, or 0 plus 1 choose 0. Yeah, so this is step 1. The total number is 0 plus 1 choose 0, right? If you remember your math. Step 2, you need to find all those. You have to delete all those who are like wrong, right? So you need to find how many of them have this property. So to do that, you have to find all the arrays with more than limits. So let's say limit is 3. You find all the arrays with at least 4 zeros in a row or at least 4 ones in a row. How do you do that? Well, that's still a combination problem. To find all the rays with at least 4 zeros in a row, you just take 0 minus 4, okay, plus ones, choose 0 minus 4. Does that make sense? So this would tell you how many arrays there are. This will tell you how many arrays there are with at least 4 zeros in a row. Because you fix these 4 zeros, right? And then you permutate the rest. I think this is the answer. Okay, I think this is the answer. I'm not super sure. Yeah, now that I'm looking at it, I think there's a little bit more. Because this works if the 4 zeros are just at the beginning. So, yeah. I think about this a little bit. So I think my math is a bit off. So this is a bit sus. This is not correct. I don't think this is correct. I think you have to multiply by something else. But I don't know what to multiply by. So I have to do the mathematics and like work it out. So it's basically a math problem. Like this is not a programming problem, guys. This is purely a math problem. Yeah. Yeah, what error is this? Stack Overflow. Okay, you are Vishal Kumar. Let's go through this after the program ends. After the thing ends. Sample question 3. Oh, nice. You got it in question 3. Yeah. So one of the integers are like you should use long, yes, but take note of this thing. So you have to return it modulo 10 to the power of 9 plus 7. Yeah. Yeah, so you managed to get it pass. Well done, Vasha Kumar. Good job. Great job. Actually, fantastic job. Okay, so I still have to do mine. This is annoying. Very annoying. Very nice. I'm always happy when people are ahead of me in the contest. This just makes me very happy to see people in the chat who are ahead of me in the contest. It means that you guys are doing good, right? I think I'm missing something in the math. This is just a math problem, and it's very annoying. Two stable arrays. No subarray has length greater than 2. Avinash, do you manage to do question 3? If you do question 3, I think it's the same answer for question 4. Unless you do question 3. Okay, so if you did question 3 using let me see. Yeah, if you done question 3, you should be able to do question 4. I don't think you can do question 3 by brute force. I don't know what the difference is. I feel like if you can do question 3, you can do question 4. It's just math. It's just mathematics. Hmm. Yeah, so I think my math is wrong. Hmm. Oh, interesting. So you use dynamic programming. So you did use a okay. So I was hasty and jumped to conclusions. So use dynamic programming, count the number of stable arrays, considering the last added number either 1 or zeros, and update the count. Yeah. Nice. Nice. Yeah. Yeah. Maybe. Or maybe question 3 is DP and then question 4 is combinations. Because I'm pretty sure you can get this just by solving the mathematics. I don't think you need program for this. I think you can just get this by solving the mathematics. Hmm. Not able to solve that. I think I'm just bad at coding. You're not bad at coding. Honestly, you can solve the second one. You're not bad at coding. You're fine. Right. This is a competitive programming. Um, this is a yeah. It's all competitive programming. You know, it's sort of like solving puzzles more than it is doing actual software engineering. It it helps you stretch your mind. It helps you stretch your thinking. But if you cannot do it, it's fine. It's just like an extreme exercise, right? Yeah. I can't do question 3 either. I feel like it's a combinations problem, but I can't figure out what the combination is. Because I don't know how to count an array with at least 4 ones in a row. I don't know how to do that. Yeah, no worries. You know, look, anybody I can tell you for a fact, anybody who comes to these weekly contests, if you do one LeetCode problem a day, you just do the daily problem, you'll be fine. You'll be fine, okay? LeetCode has a lot of like the hard problems are LeetCode are just trick questions. You will never need to do this in real life in your job. Okay? You'll never, at least I will tell you, you'll never be required to produce this solution under time pressure in your job. You may be, if you work in a more like, how do I say, advanced software company. So for instance, like, I used to work at Google, as some of you know. There's a lot of very advanced algorithms there, but I've never written any of the advanced algorithm, right? Somebody thought of the algorithm. I need to be smart enough to understand it. I don't have to come up with it. There's so many smart people there. Someone else is going to come up with it, right? You're not doing this alone. That's my point. And even for those smart algorithms that people come up with, they don't have to do it in 1.5 hours. You have days, weeks, months, whatever. Take as long as you want, right? So if you can't do competitive programming, it doesn't mean that you're bad. The interview is different. The interview, you will not be required to solve this level of difficulty. The interview, make sure you can do all the medium. You can do all the medium, most of the time you should be good for an interview. If you cannot do the medium, then that's a problem, right, for interview. They will not have this kind of problem. It's not gonna show up in the interview. Yeah, I promise you. Like this like question 4 level kind of problem. Yeah, that's not. Yeah, the medium will, yes, and some hard. But even the hard problems is going to be like dynamic programming. It's pretty straightforward. Yeah, not this kind. This kind is too complicated. Yeah. So all the contest question 4s, they're not going to show up in any interview problem. And if they do, well, it's luck, right? Sometimes it's luck. Just try a lot of times. That said, this is a medium problem. So I don't know. No, I can't. Yeah, question 4. I don't know. Yeah, sorry, Avinash. I don't know. I have not solved it. I'm pretty sure I guess my gut sense still tell me it's a combinations problem. Yeah, sorry, Avinash. I can't help you. You're in a place beyond me. Yeah, if you just use the same solution, yeah, bro is suffering some success. Well, you should be proud, Avinash and Vasha. You guys are doing well. Yeah. 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 Anyway, let me stop talking and let me start to work on this myself. See if you can make any headway. I got Q3. Is it 3D TP? I'm also actually working on Q3. I know Avinash and Vasha actually got it. I'm also doing DP. I just use I use a hash map, so I don't have to deal with so many dimensions. I have 4 things in the DP. So I have number of ones, number of zeros, the length of the combination, the last combination, and whether the combination is ones or zeros. So yeah, it's like, I guess it's 3D or 4D. I did it sort of 4D, 3.5, because my last dimension is just true or false. Yeah. So Mayush Biswas, I'm personally convinced that question 4 is a pure math question, and you can do it with math. If you do it in math, if you're good at combinations, you'll be able to solve question 4 in like 5 lines. I can't do the math. I think it has something to do with, combinations. Uh, but I can't do the math. If somebody else can think of the math, that's fine. Question 3 is, if you cannot do the math, then you can do it in DP. That's my understanding. So I know some folks are also working on question 4. Yeah, right? That makes sense, right? Because I'm sure you can calculate this without computers. I'm sure you can do a combination. It's just a combinatorial problem. Yeah. Yeah, I want to know too. Anybody solve question 4? I think DP, because it's 3-dimensional, 4-dimensional, it's a big DP, right? I don't think it scales. That's the problem. Because it's 1000 times like 4 dimensions, like we're done. We have no chance. Yeah, sorry I've been quiet. Okay. Because I've been working on question 3 still. Yeah. So question 3 is going to be 3D DP. Let me fix mine first. And after I fix mine, I will help people. Sorry about that. Sorry, I've been quiet for a while. Yeah, difference between Q3 and Q4. Difference between Q3 and Q4. The difference is the input size is much larger. Well, it's like 5 times larger. So it goes from 200 to 1000. So I think nobody in the chat, nobody in this stream has solved question 4 yet, including me. I think our guess, our prevailing guess is that question 3 you can solve using DP. And then question 4 you have to do the mathematics. It's a mathematics problem. It's a classic combinatorial problem, right? You want to find how many sequences are there with exactly 0 zeros and 1 ones, and there are less than or equal, and there's no sequence of zeros or ones that's longer than limit. This is a very standard math problem. But my mathematics is not strong enough to solve it. And so we'll see how it goes. I think I have to give on 4th. Yeah, my LeetCode rating is very bad. Yeah, I don't even know what it is. It's very bad. Yes, finally you managed to do 3. Oh, nice, very nice. Yeah, my LeetCode rating is very bad. But I think, as I said before, it's not how well you do in these contests. The goal is to learn. So as long as you learn, as long as you get better each day at programming, you're better off than the day before. And plus, if you really want to get better at programming, did 4, yes, Avinash. Wait, how do you do it? Ah, damn it. Wait, Avinash, how do you do it? Hash map, really? Very nice. Well, you're top 100 in the whole contest. Very nice. Oh my god. Very nice, Avinash. So what do you do? Do you just use a hash map instead of array for the DP? Or did you? Yeah, OP by. So that much Hindi I know. Nice, very nice. Yeah, you're top 70 because so far only 65 people. Holy shit, Avinash. You're top 65. That's amazing, dude. Wait, what optimizations do you do? Oh, he's gone. He's gone off to celebrate. Man, I want to know too. I want to know too. So it sounds like Avinash did it using DP. Still. Nice. Yeah. That's super nice. Okay, contest is gonna end soon. In 10 seconds. So for rest of us, we're not able. Oh, nice. How do you do it, Vasha? Do you also do DP with optimization? Yeah, I spent too much time trying to solve the math problem. I was convinced that is. Yeah, what's the change? What do you do that's different? Yeah, okay. Anyway, the contest is ended. Let me do a quick announcement, which is while everybody is here, which is we're gonna go through all the answers, especially question 4, because I don't know what the answer is so I'm hoping to solve it. If you have problems with question 1 and especially question 2, we will go through it. We'll go through all of them. Second thing is, while people are here, hit and drop. While people are here, just a shameless plug. If you enjoy my content, if you like this stream, please throw me a like and subscribe. It helps me out a lot.
You being here is great already. I want to say it always helps. But if you like, if you share this with your friends or in other groups that you're in, it will be really helpful. If you like other LeetCode content, make sure to check out rest of my channel. I'm trying to be more consistent about uploading like daily problems. So I'll solve daily problems and upload the solutions there. Yeah, that's it. And if there's other contents that you want to see, like I want to talk about things like how to do well at job interviews, what the life of a software engineer at Google or somewhere else is going to be like. If you like those kind of contents, drop me a chat or comment in the videos. Let me know. I will put out some of those too. Okay, the contest ended. I hope everybody had fun. Everybody learned something. It was I will try to tell. I'm going to read Vasha's message later, but I am going to get a swig of water and come back. We'll go through all the problems one by one. Not problem 4 though, because I don't know how to solve problem 4. But we'll go through the first 3 one by one. Be right back. I will try to tell with hash table. Yeah, interesting. I'm going to try it again. I'm going to try it later after the contest ends. All right. Let me just reset the screen and then do my usual spill. We are discussing solutions for LeetCode Biweekly Contest 129. Jump to specific questions using the timestamps in the video description. And please check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay up to date on new videos. All right, let's go through 25 minutes. So people took a while. For question 4. Yeah, normally these people do it in like 10 minutes, which is crazy. I don't know how you do this in 10 minutes. I can't even finish my hamburger in 10 minutes. All right. Nice. 2 problems decided ranking of the yes. It is a little bit annoying. Red Finance, I agree with you. Very nice that you're under 1000 rank. I am so happy for you. Okay, cool. So let's talk about all 4 questions one by one. So question 1 is make square with the same color. You are given a 2D matrix grid of size 3 by 3 of only characters B and W. So B is black and W is white. Okay? So your job is to find your task is to change the color of at most one cell so that the matrix has a 2 by 2 square where all cells are the same color. Return true if this is possible. Okay? So for instance, this is a 3 by 3. This problem is kind of nice because you don't have to guess the n. The n is just 3. It's fixed. right? The n is just 3. Yeah. So what that means is, let's say you got a 3 by 3 matrix like this. Here's a 2 by 2 matrix. Here's another 2 by 2 matrix. And then here's one more and one more. So there are 4 2 by 2 matrix in total. 4 2 by 2 squares in total. Okay? And so your job is to check if at least one of these squares has all 4 cells of are such that you can change at most one cell so that it has all 4 cells of the same color. This sounds a little bit confusing, right? This sounds a little confusing, but what it's actually just saying is that if the 2 by 2 square has 3 cells of the same color, then you're good to go. You're just checking whether it has 3 cells of the same color. So what do you do here? This is not this is a fairly standard question. I hope most of you got it. Okay. So the trick here, you can is to first go through all the 4 2 by 2 arrays. I just did a for loop because, but you don't need to do a for loop. You can just check each grid normally. And what I did is I checked each one of the 3 grids and compared it with the first guy. So if it's the same as the first guy, I add 1, right? I just count how many of the out of the 4, how many of them are the same color as the first one. So if the answer is 1, 3, or 4, if all 4 of them are the same color as the first one, if 3 of them are the same color as the first one, or if the first one is its own color, that works too. So if this is 1, 3, or 4, then return true. Then it'll work. This is actually, I think this is like not equals to. I think so. Yeah. Okay, so that's it for the first one. The only tricky part is being able to identify all the 2 by 2 arrays. So for that, I use a for loop just because n is unspecified. It's normally unspecified, but since n is 3, you can manually identify the 4 arrays yourself. Okay, question 2. You're 292. Very nice. Congratulations. Very nice, very nice. Yeah. Yeah. Is that highest rank you got? That's crazy, man. Okay, so second question, question 2, right angle triangle. You are given a 2D Boolean matrix grid. So return an integer that is the number of right triangles that can be made with 3 elements of grid, such that all of them have a value of 1. Okay, first, let's understand what this right triangle means. A right triangle is 3 elements of a grid that one of them is in the same row with another element and the same column with the third element. So these 3 things, these 3 guys will be a right angle triangle. Okay? You need 2 people to be in the same column, and the third person has to be in the same row as one of them. So 2 in same column. The third one in the same row. Okay, that's the constraint. So this will have no right angle triangle. This will have a right triangle. Notice that this 1, 1, and 1, they are not next to each other. They are far apart. Okay? In this example that we see here, this, and this form a right angle triangle. They don't have to be next to each other at all. They can be pretty far apart. So how do you do this? Well, here's the way I did it. Essentially what I want to do is to find okay, here's my strategy. My strategy is I go through every column. For each column, I want to find 2 people in the column. If the column only has 1 person, then we're done. If I find that if there are at least 2 people, then I go through each pair I go through each pair. And then for each of the pairs, I want to see how many triangles I can make with the pair. So for instance, in this column, there are 3 ones, right? So I'm going to go take this first pair, for instance. Let's say this guy and this guy. How many triangles can I make with these two as a spine? Well, I'm going to look at the rows. I'm going to look at if either of them has an additional 1 at the row. This guy has a 1, right? So now I can form a triangle this way. So my count is going to increase by 1. Okay. Next, let's look at the next pair. Next pair is this one. How many triangles can I make with these two guys as the spine? Well, I can make this. I can make this. Right? I can make 2 of them because there's 2 guys on the row. Right? So my count will be increased by 2. What about this one? This one and this one. If I choose these 2 as my spine, how many triangles can I make with them? Well, there are 2 here, so I can make 1, 2. But there's 1 here too, so I can make another 3. Right? So now you're starting to see the pattern. If you go through each column, for each pair of ones, you can count how many triangles they make by adding up their rows. Okay? So you can actually optimize this a little bit. So one way to optimize it is just count how many there are in each row. There are 2 in each row. There's only 1 in this row. There's 3 in this row. So I know if I'm paired with this guy, he's not going to help me make additional triangles. I have to use people on the same row as me to form the third leg of the triangle. So first step is I'm going to count how many. Second step is for each of these columns, right? For each of these columns. That's the first optimization. Second optimization is for each of these columns, you realize that you don't actually have to you compute every pairwise combination. There's actually a faster way to do this. All you have to do is to take each number here, you count how many siblings he has, and you multiply that by the rest. Because take for example this guy here, he has 1 sibling, right? 1 guy on his 1 row mate. How many triangles can he form? Well, he has 1 row mate. There's 2 different people who can form triangles with him. So 2 times 1 is 2. So same thing, this guy over here, this guy, he has 2 row mates. You know, because it's 3 minus 2 is 3 minus 1 is 2. How many triangles can he form? Well, he can form 2 times 2, which is 4. So that's another way of looking at it. So with those 2 optimizations, you can basically solve the problem quite straightforwardly. So this is what I did. First, I do a row count. I pre-process by figuring out how many there are in each row. And then basically, I don't actually need this. So basically what I do is then for each... Oh, what happened to the rest? Yeah. For each column, I just do row times the number of ones in that column. I count how many ones there are in that column. Oh, picture is gone. So the vertical one, multiply how many ones there are in the column, multiply by how many ones there are in the row, next in the same row as me. And I add that to count. And I do that for the whole array, and that will be my solution. This is actually quite... I think this question, I feel that this question is unusually difficult for question 2. Normally question 2s are quite easy. Okay. Yeah. Okay, question 3. Okay, question 3. Question 3 is an interesting one. Okay, so question 3 goes like this. you're given 3 positive integers, 0, 1, and limit. Okay? A binary array R is called stable if the number of zeros in R is exactly 0, number of ones is 1, and then the subarray of R with a size greater than limit must contain both 0 and 1s. Okay? So what this means, let's parse each of the requirements in turn. This is these two requirements pretty straightforward. All it tells you is that there must be, it just tells you the size of the array. It tells you that you have to have exactly zeros and exactly 1 ones. This tells you the size of the array. This requirement is a little bit more interesting. This requirement, if you read it carefully, just says that you cannot have an array. Your array cannot have a subarray with more than a limit 0 or 1s in a row. So let's say your limit is 3. You cannot have more than 3 zeros or 3 1s in a row. You cannot have sequences that contain like 3 zeros or 3 1s. Okay? So that's what this third requirement is talking about. So how do you calculate this? At the start, I thought it was a combination problem. I'm still convinced that it is. I spent a lot of time on that. I couldn't manage to figure it out, unfortunately. So I basically went back to DP, like what many of you did. So how do you make this a DP problem? How do you do this in DP? Well, think about the solution. So in DP, we always think of things incrementally, right? In DP, when you want to solve, the answer for n equals for n, you have to look at n minus 1. How do you get the answer for n from the answer from slightly simpler versions? Okay? So you think about the answer for, let's say, when you have x zeros and y ones, right? How do you get this? Sorry, let me just use different names. When you have 0 zeros and 1 ones, right? How do you get the answer for this from an earlier answer? Well, one thing you can think of it is you can sort of grow your array, right? So you start with length 0. That's just 1. If you want to add length 1, you can either add 1 or you can add a 0. You add a 1, then it becomes 1. Then the number of arrays that you have that has 1 ones in it is going to be 1. Okay? So you have to keep track. Basically, there are 4 things you need to keep track of. Or there are 4 things that I kept track of. The number of ones, the number of zeros, the last combo, okay? Because of this limit, right? Because of this limit, you have to keep track of what's the size of your last combo. So your last combination, your last combo cannot be longer than limit. If your last sequence is already at limit, then you cannot add the same number. Okay? So let's say there's 0 ones and 1 0. Your last combination is going to be 1, and its 1 is going to be false. Okay? This is just this thing here. You can add 1 to this. I'll have 1 1, 1 zeros. My last combination is going to reset because I changed from my last combination being 0 to last combination to 1. Okay? So my last combination is going to reset. Now if I add a 1 to this, if I take this, I add 1, 0, 1, 1. Okay? My 1s will be now 2. My zeros will be still 1. And the length of my last combo is now 2. And it's still true. Okay? So what you'd want to do is basically you want to take whatever sequences you have calculated, right? And then you want to, for each of these rows, you want to either add 1 to it or add 0 to it. If you add 0 to it, then the number of zeros will increase by 1. If you are at you're at max already, then you can't add any more zeros to it. If you add 0 to it, and your combination, the last digit is 0, then your combination, the length of your last combo is going to increase by 1. Yeah, and if your last combo is at limit already, you can't increase it anymore. So that's how I did it using DP. Yeah, unfortunately I didn't manage to finish it in time, but I'll show you what I got. So let me just check the chat. Oh, you got doxed? Hackers.io. Nice. We got a super spy here. Okay, so this is how I would do it. So I start with a DP table. I use a dictionary rather than an array because I have like a lot of stuff here, and I just don't want to deal with how much stuff there is, right? So I'm gonna have I in range 0 to 1s, 0 plus 1. That is the length of my my array. Every time I go through the for loop, my array increases by 1. Okay, so at the beginning, my array is empty. There's no combo. There's like it's just empty. Okay, and then for each of the possible rows in my array, in my DP table, I can either add 1 to it. If I want to add 1, I need to check that the number of 1s is not at max. If I'm capped at the number of 1s, then I can't add 1. I can only add 0s. Or I can add 0s to it. So same thing, if I want to add 0s to it, it cannot be more than 0 zeros. Okay? If I want to add 1 to it, I want to check, is my last combo 1 or not? If my last combo is 1, then what I want to do is I want to check if my last combo is at the limit. So if the last like 3 digits is at is 111 and my limit is 3, then I can't add any more. This is actually less than, not. Yeah, this is less than equals limit, not equal. Yeah, then I can't add any more. I can only add if I'm not at my limit yet. Like if the last n digits is not a 1, right? Else, then I'm gonna say now my new last digit is a 1, is a true, and I'm gonna reset the combo to 1, right? So I'm gonna do that. I'm gonna repeat for zeros, the same thing, and then I'm gonna print the DP table at the end. So that's pretty much it. So the DP table looks something like this. You know, there's 0, 0, there's no combo, and then of length 1, this will be 1, this will be true, 1 false, and then length 2, you take this, you can add a 1 to it, in which case it will be 2, 0, you add a 1 to it, this will be length 2, this will still be true, or you can add a 0 to it, in which case this will be 1, 1, the last digit will be a 0, so this will be false, and it could be length 1. And then you keep doing this, right? You keep doing this. So this actually will save you time because all the sequences in the same row are counted the same way. You don't care, right? You don't care what the first n digits are. You just care that there are this number of 1s, this number of zeros, and the last this number of digits are all 1s or zeros. Yeah. So that's pretty much it. Let me check the chat if there's any questions. Yeah, there's no questions. Yeah, good job to everybody who managed to get a ranking. I think this question 3 was kind of tricky. My guess is at least some people did the same thing as me, which is we're convinced that it's a combinatorial problem and we keep trying to solve it and kept failing. and then ran out of time to do the DP. But very good job to everybody who managed to complete 2 questions and get a ranking. I'm a little bit jealous of you guys, but I am also immensely proud. That's amazing. That's freaking amazing, man. So good job to Hackers.io, Vasha, and someone else, and Red Finance, and someone else, Avinash. Yeah. Okay. So I unfortunately for question 4, I don't know how to solve it. I guess you can use the DP, you just make it more optimized. I'm not super sure. I'm going to try it on my spare time, and I'm going to see if there's a way to get it done. Yeah, thank you. Appreciate it, bro. I try to make the stream sort of accessible and educational. The goal is to help people who get stuck on the easier problems. The goal of this stream is to hopefully everybody levels up a little bit. As some of you know, I actually teach freshmen in college. So this is year 1, freshers, as you guys would call it. So hopefully everybody learns something a little bit more today. And I also enjoy doing LeetCode. It's fun, right? It's fun doing puzzles. It's so fun. Yeah, so that's it for today's stream. Let me see if there's anything else. You can ask questions. If not, then I think we are good to go. No? All right, cool. Then once again, yeah, it is. Yeah. Once again, congrats to everybody who got a placing. Allow for new train of thought to be opened up. I'm glad, you guys are a lot younger than me, and when I was your age, I was definitely not as good as you guys. You guys are really good. I'm really impressed. So once again, signing off, and see you all next week. Ciao. Tomorrow morning weekly, I only do 1 weekly a week. So if there's bi-weekly, I'll do the bi-weekly. And if there's no bi-weekly, then I'll do the weekly. So I will not be streaming tomorrow morning for the weekly. I will be trying though, because I do better off stream than I am on stream. I don't have to talk. So I'm gonna see if I can score all 4 questions tomorrow. Either way, take care, guys. Bye. Yeah, Hackers.io, if you do it, I hope you do it, and I hope you do well. All right. Bye for real this time. Ciao.